Alright folks, let's do number 18. This is going to be a pretty fun problem for me because it's red. And alright, let's get started. A dive bomber has a velocity of 280 meters per second at the angles of theta below the horizontal. When the altitude of the aircraft is 2.15 kilometers, it releases a bomb which sequentially hits a target on the ground. The magnitude of the displacement from the point of release to the bomb to the target is 3.25 kilometers. Find the angle theta. So I encourage you guys to pause this video and give this problem a shot. Presuming you pause this video and give this problem a shot, let's draw this. So you have a bomber here. Let me redraw this. This object is going to be h, I'm going to define that to be 2.15 kilometers. And it has the initial velocity of 280 meters per second. And this object is going to hit the ground. It's going to travel this parabolic pathway once the bomb is released. So in other words, that's just going to carry the component initially of the bomber. And it says that the magnitude of the displacement, which I'll call d, I guess, of the point of release to this bomb is going to be specifically 3.25 kilometers. Now, this is the point of release. That's not the actual pathway of the bomb. So think about that, folks. And notice that this is really just, if we're given h, if we're given d, that means that we know what this specific x is. So we can use that information to pretty much already know what x is. All right, so that's pretty much it, folks. And my goal is to set up the motion graph. So let's do that. Let's write the motion graph. I'm going to define that to be L. L is going to be the vector x and y. X is specifically going to be v naught, and this is going to be theta released from the horizontal. Is going to be v naught cosine of theta naught, I'll call it theta naught, I guess, times the time. So that's going to be the position for x, depending on whatever time is, whatever specific time it is, that's the position for x. Y, so the graph for y, or the position for that y, is going to be the h plus, or minus in this case, v naught sine of theta naught t minus g over 2t squared over 2. So this whole thing will plot up the graph, and this is going to be x in terms of t, y in terms of t. Now, we know what x is, we know what y is, we're going to call that 0. We don't know what the angle is, and we are given the initial speed. And so, but notice the unknowns, folks. What are the unknowns that we don't know? We don't know the time it takes for it to hit the ground. However, the rest of the variables is known. In fact, this is literally all the information we're going to need to solve this problem. It's really just this, folks. I thought this was going to be a little harder problem than it is, especially when it's red, but it's not. So it's really just knowing your math, setting it up, and that's it, folks. It's really that straight, it's not hard, folks. Anyways, so think about what you have here, what I set up. This is the motion when you were to plot x and y. The motion here is going to be the x-axis and the y-axis. And this motion graph is going to look like this once it's dropped. It's going to have some initial component. Well, it's actually going to look a little more downward, but whatever. It's going to have a little component, a little initial velocity in that direction, whatever that direction is, and it's going to go down. The horizontal components of the velocity will remain the same, but the vertical component will be affected by gravity, and it's going to increase the component as it hits down towards the ground. And since we're given what d and h is, we know what technically x is, so we can use that information to set up one of the equations, and then the only thing you have is two equations, two unknowns, so this is definitely solvable. It's just using your rules of mathematics more than anything else for you guys. So anyways, I'm just ranting here, but I did took 10 milligrams of THC So as I'm doing this video, but I don't know why I said that. But anyways, folks, anyways, you guys should be able to solve this. All right, folks, we are going to be solving for these variables here. So we're going to solve for the angle theta. In order to do this, we're going to have to set this up. Now, I don't know how to solve this at the top of my head, but I'm going to spend an extra video of this, maybe on the side video, to solve for this angle. So what I'm going to do is I'm going to let y be 0. I'm going to let h be h. I'm going to let t specifically be x over v naught cosine of theta naught there, and I'm just going to substitute in there. That's going to be my first step. And normally I don't really do this on these videos. I never really show the algebra steps, but in this case I'm going to make an exception. I might make the video a little longer than it usually is, but that's all right. So so if you guys want some algebra steps here, I guess I'll do it, because it might be a little more involved than you guys are used to. So I'm going to let this be this, and I'm going to rewrite this as minus g over 2x squared over the v naught square. And I'm going to write 1 over cos square of theta as secant square of theta naught. And the reason for that is because I want this to be, I want to solve for the angle. And I don't think I'm going to get much. Oh, wait, we are given the inertial velocity. Oh, my God, my brain is having a short-term memory at the moment. But that's all right. So this is going to be minus that, minus the sine tangent of theta naught times x. And that's going to be plus h. And that's going to be equal 0. So I'm going to rewrite tangent square of theta as 1. This is going to be specifically secant square of theta. So I'm going to rewrite this as minus g x squared over 2 v naught square. I'm going to put tangent square of theta on the side, and I'm going to put this in the middle, minus tangent of theta naught times x, and I'm going to write, add it to, and since this is going to be 1 plus that, I already took that into the account. I'm going to rewrite the same thing. I'm going to put h minus gx squared over 2 v naught square equals 0. All right, folks, once you put this in the quadratic formula, get that set up, then you just plug it in there. Remember that the x is known, so there's the Pythagorean theorem, because this is going to be a well, you guys, all right, anyways, once you get that angle, the angle is going to be 3.5 degrees. All right. I hope this helps.